For months, astronomers told the public that 3I/Atlas would simply be a spectacular flyby, a harmless, interstellar visitor brushing past Mars, before disappearing into the darkness beyond our solar system. But space rarely delivers harmless events without a deeper reason. And now the James Webb Space Telescope, our most advanced eye in deep space, has released new observations that turn that entire narrative upside down. The calculations have shifted. The trajectory has changed. And for the first time, scientists are quietly saying the one possibility no one wanted to hear. 3I/Atlas may collide with Mars. But the story is no longer just about a comet. It's about precise maneuvers, rhythmic gas pulses in an object that acts less like drifting debris and more like something engineered. The deeper researchers dive into the data, the more obvious the pattern becomes. 3I/Atlas is not simply wandering through space. It's steering, adjusting, targeting, and the Mars now sits directly in its path. Whatever this object truly is, it does not appear finished with our solar system. Let's take a closer look. When 3I/Atlas was first discovered on July 1st, it appeared similar to other interstellar visitors, a rapidly moving object surrounded by glowing coma, entering the solar system at an extraordinary speed of nearly 87 kilometers per second relative to the Sunday. At that velocity, the distance between Earth and the Moon could be crossed in less than 80 minutes. Yet the real surprise was not its speed. It was how it behaved. Comets normally slow down, fragment, or settle into stable paths as they approach the inner solar system. But 3I/Atlas began doing the opposite. It accelerated slightly at first, but with a steady consistency that quickly raised concerns. Even more troubling was its trajectory. The path of the object started tightening, almost as if subtle course corrections were taking place. Meanwhile, its coma, the glowing cloud of gas and dust surrounding it, suddenly doubled in brightness within a matter of weeks. Spectroscopic analysis revealed something unprecedented: intense spikes in ultraviolet emissions combined with massive CO2 outgassing levels far beyond anything previously recorded in a comet. Instead of acting like a passive chunk of frozen rock, the object appeared to behave more like a guided projectile. Then Webb's deep field sensors detected the anomaly that changed everything. Rhythmic pulses emerging from the object's tail, not chaotic jets caused by sunlight. Melting ice, but structured bursts, appearing exactly every 17 minutes. A pattern, a rhythm, a maneuver. As observations continued from Webb, Gemini South Telescope, and NASA's Jet Propulsion Laboratory, the numbers began telling a far more disturbing story. What once looked like a harmless near miss slowly evolved into something much more dangerous. Updated calculations now placed the object's closest approach at just 1.95 million kilometers from Mars, a razor-thin margin on a cosmic scale. Even worse, simulations suggested that an additional acceleration of only 10 km/s, a small fraction of what appears possible from those gas pulses, could shift the object's path directly toward the planet. Think about that for a moment. A tiny burst of thrust could transform a near pass into a direct impact. This type of control is unheard of in natural celestial bodies. It's as if 3I/Atlas is using its own outgassing as micro-thrusters, adjusting its approach the way a spacecraft might. More disturbing still, those thrust bursts align perfectly with Mars' orbital plane. Scientists are no longer simply tracking a comet. They are watching it aim, and the potential impact window is rapidly narrowing. Between September 19th and September 30th, any single burst could shift the trajectory enough to push the object into collision. The alarm is no longer limited to Amateurs or science fiction enthusiasts, even respected scientists, have begun considering more radical explanations. Among them is Harvard astrophysicist Avi Loeb, whose team has proposed a controversial idea. 3I/Atlas might not be natural at all. It could be an engineered probe. Radar signals reflected from Mars orbit via the Mars Reconnaissance Orbiter and the Goldstone Deep Space Communications Complex returned echoes that resembled metallic surfaces rather than the icy composition typical of comets. NASA insiders reportedly described the radar reflections as unlike anything previously recorded, combined with high-exposure amateur images showing green needle-like beams extending toward Mars, synchronized with those gas bursts. The mystery only deepened. 3 luminous streams seemed to converge toward the planet itself. According to Loeb's hypothesis, 3I/Atlas may be deliberately approaching Mars, not merely to collide, but perhaps to deliver something, a probe, a signal, even biological, material. Whatever the purpose, the approach appears deliberate, and humanity is watching an operation unfold that we barely understand. If the object actually strikes Mars, the result would be catastrophic, with a mass estimated near 10 billion tons and a velocity approaching 57 kilometers per second relative to the planet. The energy released would exceed 2 million megatons, thousands of times more powerful than the largest nuclear detonation in Earth's history. The resulting crater could reach 60 kilometers in diameter and several kilometers deep, blasting debris into orbit around Mars. Some fragments could even escape Martian gravity and travel into interplanetary space. Eventually, some of that debris might reach Earth, but the consequences extend far beyond rock and dust. Mars currently hosts numerous scientific assets, rovers, orbiters, and experiments searching for evidence of ancient life. An impact could destroy decades of research in seconds. It could wipe out communication, infrastructure, and contaminate regions scientists have carefully protected for future study. Space agencies including European Space Agency, Roscosmos, China National Space Administration, and Japan Aerospace Exploration Agency have already begun internal discussions regarding planetary defense protocols, not against an alien fleet, but against a single mysterious object that behaves far too much like a vehicle. For decades, scientists have suspected that Mars may once have hosted life, and perhaps still does deep beneath its surface. Underground lakes, dormant microorganisms, and ancient ecosystems trapped beneath layers of frozen soil remain a possibility. If 3I/Atlas strikes the planet, the impact could rupture deep geological layers that humanity has never reached. And if the object itself carries organic compounds, or worse, engineered biological systems, the collision could create a planetary-scale contamination event. Some researchers have begun calling this possibility reverse panspermia, not life spreading from Mars to Earth, but life being intentionally seeded onto Mars, which raises a disturbing question. What if the purpose was never destruction? What if Mars is the destination because it's meant to become something else? When the James Webb Telescope performed one final ultra-deep observation of the object, the results were briefly kept classified before partial data was released. According to leaked reports, the telescope detected traces of synthetic polymers mixed among natural gases, molecular structures resembling plastics and carbon nanotubes. These materials do not naturally form in space. They are engineered. Even stranger were unusual isotopic signatures in carbon and hydrogen that do not match any known solar system object. In simple terms, 3I/Atlas appears to contain substances that should not exist in deep space, and every bit of that material is heading toward a planet that may still harbor life. As concern grew, NASA unexpectedly went silent. Public briefings slowed. Data, streams from Martian missions showed unusual gaps. And when journalists asked about impact scenarios, answers became vague. Then a leaked internal transmission revealed a chilling phrase. Impact protocol initiated. No one outside classified circles knows exactly what that means. But insiders suggest that encrypted signals were sent from Earth-based stations to equipment currently operating on Mars. Why transmit signals to Mars when there is no known way to stop the object, unless those signals were never meant to defend the planet, but to prepare it? If 3I/Atlas possesses even limited autonomous intelligence, it might react to energy signatures, encoded pulses, or navigation beacons. And if Earth has now activated those systems, we may have unintentionally confirmed that we are listening. Worse still, we may have confirmed that we are responding. And whatever intelligence, if any, is behind this object may now know that we are aware. At that point, researchers from the SETI Institute attempted something unusual. They converted the object's trajectory, velocity, and gravitational vectors into binary data, essentially translating its path through space into a digital language. The result was astonishing. Instead of randomness, the data produced repeating numerical patterns associated with atomic numbers, carbon, oxygen, silicon, iron, the building blocks of life and technology. Interwoven among them were sequences of prime numbers and recursive spacing, patterns often used in deep space communication protocols. In other words, the entire flight path of 3I/Atlas might itself be a message, not transmitted through radio waves, but through motion. If that interpretation is correct, then humanity may not simply be observing an incoming object. We may be witnessing a communication event, and the potential impact with Mars could be part of the message itself. If it hits, that says one thing. If it misses, that says another. Either way, the answer may already be written in the stars. And now the only question left is this. What exactly is the message trying to tell us? But the deeper scientists looked into the trajectory of 3I/Atlas, the more unsettling the situation became. What first appeared to be a simple orbital calculation problem slowly evolved into something far more complex. Each new set of measurements forced astronomers to rewrite their predictions. Each update shifted the timeline slightly closer to something no one had prepared for. At the center of this investigation was the powerful gaze of the James Webb Space Telescope, orbiting nearly 1,000,000 miles from Earth at the Sun. Earth L2 Webb was designed to study the earliest galaxies in the universe. But now its attention had turned toward a mysterious visitor racing through our own solar system. Using its infrared instruments, Webb began analyzing the chemical composition of the object in unprecedented detail. Normally, interstellar comets reveal a mixture of frozen water, carbon monoxide, methane, and dust. But the spectral signatures coming from 3I/Atlas look different. Some wavelengths matched known compounds. Others simply did not correspond to anything commonly found in natural comets. One particular emission line puzzled researchers the most. It appeared at intervals almost like a heartbeat. Every few minutes, the signal intensified before fading again. The pattern was so regular that astronomers initially assumed it was an instrument error. After running the observations again, however, the pulses returned exactly as before. That was the moment when some scientists quietly began discussing a possibility that had never seriously been considered before. What if the object wasn't entirely natural? Among the first to openly question the nature of the visitor was astrophysicist Avi Loeb. Loeb had already sparked global debate years earlier when he suggested that the interstellar object, ʻOumuamua, might have been artificial in origin. Now, with 3I/Atlas showing even stranger behavior, the discussion resurfaced with renewed intensity. Loeb's team analyzed the object's acceleration profile instead of the random outgassing typically seen in comets. The burst from 3I/Atlas seemed to occur in directional jets. These jets produced tiny adjustments in velocity, almost as if the object were correcting its course. Even a small adjustment in deep space can have enormous consequences over millions of kilometers. And when astronomers projected these adjustments forward in time, something alarming emerged. The path intersected with Mars. At first, the probability of impact appeared extremely low. Space is vast, and even objects passing close to a planet usually miss by enormous distances. But each new maneuver reduced that margin slightly. The updated models showed that if the current pattern of thrust pulses continued, the object could shift into a collision corridor within weeks. This discovery triggered quiet communications between multiple space agencies. Engineers at NASA, the European Space Agency, and China National Space Administration began reviewing contingency plans. But unlike asteroid threats to Earth, there was little anyone could do in this case. The object was moving far too fast to intercept, and it was millions of kilometers away from any spacecraft capable of approaching it. All humanity could do was observe. Meanwhile, orbiting Mars itself was the Mars Reconnaissance Orbiter, a spacecraft that had spent nearly 2 decades mapping the planet's surface. Using its radar instruments, the orbiter attempted to bounce signals toward the approaching object. Scientists hoped to learn more about its internal structure. The echoes that came back were strange. Instead of the scattered reflections expected from a porous, icy body, the signals appeared unusually coherent, as if they had bounced off denser material. Some engineers even noted that the reflection pattern resembled that of metallic surfaces. The result was not enough to prove anything unusual, but it was enough to deepen the mystery. As days passed, the brightness of 3I/Atlas continued to grow. Amateur astronomers around the world began capturing images of its expanding coma. Forums filled with speculation, and within weeks the object had become one of the most discussed astronomical events in years. Yet the most unsettling discovery came from a team studying the object's rotation. By analyzing subtle changes in its brightness, they determined that 3I/Atlas rotated once every 34 minutes. That alone was unusual, but the real surprise came when they compared the rotation rate with the timing of the gas bursts. The jets occurred exactly every half rotation, which meant they were not random at all. They were synchronized with the object's orientation in space. If natural forces were responsible, such perfect timing would be almost impossible. But if the bursts were being triggered intentionally, the pattern suddenly made sense. Each rotation exposed a specific region of the object toward the sun, and at that precise moment, a jet fired, like a thruster, slowly altering the object's path. Weeks later, another observation arrived from the SETI Institute. Researchers there had taken the timing of the jets and converted them into a numerical sequence. When plotted on a graph, the intervals formed repeating clusters of prime numbers. Prime numbers are one of the simplest mathematical patterns capable of signaling intelligence because they are not easily produced by natural random processes. Scientists have long considered them a potential universal language for communicating across the cosmos. The implications were staggering. If the pattern truly represented prime numbers, it meant that the behavior of 3I/Atlas might not be random physics at all. It might be deliberate communication. At that point, discussions within the astronomical community shifted from curiosity to caution. Data from Webb and other telescopes was reviewed again and again. Teams searched desperately for simpler explanations, unknown chemical reactions, unusualized compositions, anything that could account for the observations without invoking technology. But every attempt seemed to create new questions, and all the while the object continued its approach toward Mars. If the calculations were correct, the closest encounter would occur in just a few months. Whether it would strike the planet or pass safely by remained uncertain. The difference between those two outcomes depended on extremely small changes in velocity, just a few meters per second, a whisper of thrust in the vacuum of space. For now, the world's most advanced telescope kept watching from its silent orbit around the sun. The James Webb Space Telescope continued collecting data, sending faint signals back across nearly 1,000,000 miles of space. And somewhere out there, far beyond the orbit of Earth, an object from another star system continued adjusting its course. Whether it was a natural wanderer or something far more extraordinary was a question no one could yet answer. But one thing was certain. If 3I/Atlas truly was steering itself toward Mars, then humanity might be witnessing the first deliberate interstellar arrival in the history of our species. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.